Okay, for this next example, I'm going to do something similar with this code. So this code will look like the last video, and I'll talk about this in just a moment. But let's come back up here to the purpose. So the purpose of this video is I want to fork three effects and then show how to use both join and another function I haven't shown yet called joinAll. Another thing I want to do is I want to use thread name to show that each print line statement is on a different thread. So what I mean by that is I have this function here named thread name, and you can see what it's doing is it's calling the current thread method on the thread object, and then it's calling get name on that. So get the current thread, then get the name of that thread. And you'll see how I use that in just a few moments. And then the third point here is to show the difference between join and join all. And we'll get to that in just a few moments. So I showed thread name already. Let's take a look at this first line of code here. So this one is called print hello, and it's very similar to what I did before. I do a zero sleep for 750 milliseconds, and then I call succeed. And I want to note here that I am using the Scala print line function and not this Zio function. And that's because the Scala function has better output for what we're trying to do. So that's why I'm using that inside of succeed right here. And I show that in this note right there. But coming back here, I have a print line. I've wrapped that with succeed. And what I'm doing in print line is I call that thread name function and then print hello. So this is creating a string right here. And the first part of that string comes from the thread name function and then adds hello after that. Then the second line is the print world over here. So in this one, I sleep for 500 milliseconds, and then I do basically the same thing that I just did, and the only difference is that this has world here instead of hello. So it's going to call thread name and then world. And then I have the background task, which I believe is very similar to the last video. Sleep for 1 second, and then do a similar thing, calling thread name here, and then printing background task completed right there. So if you watch that last video, this looks pretty close. I think I changed the numbers for that last video. Other than that, it's pretty close. But now if we come down to the run value here, and then our for expression, what I do is I'm going to fork the background task. That creates one fiber. Then I'm going to fork the second one, which is the print hello effect right here. So that one's going to be forked. The first one I call B, the second one I called H. And then when I do print world and fork it on a third fiber, that one is going to have a variable named W over here. So what's going on in this code is we're creating three fibers, and those are three fibers in addition to the main fiber. So you can think of this code as running on the main fiber, or at least the start of this code is running on the main fiber. Then this runs on one separate fiber, then this is a second fiber, then this will be a third fiber. That's the way that works. But if you recall, these are all effects. Nothing really happens yet, and what that does is allow us to join these three fibers on the main fiber. So assuming that you saw the two previous videos, you now know that what we're doing here is we're saying, hey, Mr. Main Fiber, I want you to wait until B is done, and then you're saying, Mr. Main Fiber, I want you to wait until H is done, and then I want you to wait until W is done on that third line right there. So now if you're comfortable with the way this works, and I suppose I could add some comments here and say, well, this one is going to take 1,000 milliseconds. And then which one is hello? Hello is 750 milliseconds. And then world will be 500 milliseconds. So then the question to you is, what do you think is going to happen in this code right here? So let me save that, and we'll come over here and watch that, and I called that A002, A002, and let's go ahead and run that. And the output over here tells us what happened. World is printed first, that was the 500 millisecond one. Hello is printed second, that's the 750 millisecond one. And then the background task completed is printed third, and that was the 1000 millisecond one. So this gives you a really good idea that those three ran in parallel. And the other thing I can tell you here is that this is the output that we're getting from this thread name function right here. So this is telling us that world ran on a thread that has this name. So it's zscheduler worker 5. Hello ran on number 6, and then background task ran on number 11. And these numbers will change quite often, so you don't have to get too hung up on those. If I come over here and just make a change, we might see a change in those right away. And there you go. So these are showing different worker numbers. The only thing that's important for what we're doing is seeing that, oh, this guy here, you could think of it as, oh, this one is running on fiber number 7. This one is running on fiber number 1. This one is running on fiber number 3. And really, the only important part about that is they're running on 3 different fibers. The names don't really matter. The only thing that matters is that they are indeed running on 3 different fibers. And now over here, I have some notes that I wanted to make sure I discussed with you. So the first note is join. And the way it works is it suspends the main fiber until the child fiber completes. And I've talked about this in several previous videos. So it suspends the main fiber until the child fiber completes. The second note here is if the child fiber has already completed by the time you join it, the join call returns immediately. So that's really interesting because what I did intentionally was I put the B fiber, the one that took 1,000 milliseconds first, followed by the other ones that should have finished before B finished. So you can think of the code as waiting to join B right here for 1,000 milliseconds. But what happened, and that comes to the second note right here, is that H and W have already finished. So that comes to this note that says if the child fiber has already completed by the time you join it, the join call returns immediately. So H and W have already completed by the time we join them. So those join calls return immediately. Now in simple code like this, that works okay. Then my second note here is that I wanted to intentionally join with these calls in the sequence B, H, and W as I just discussed. But I want to come down to this point here where I say however, and that is that using join in sequence will wait for each fiber one at a time, but that doesn't take advantage of the concurrency that Zio can provide for you. So you could think up here that if I wanted all 3 of these to come back as soon as possible, so they could do whatever they're doing and then maybe give me some output as fast as possible, I'm not allowing for that up here. And the note here is that if you want to join all the fibers at once, you should use fiber.joinAll instead. So what I can do here is just copy that code, come back up here, comment that out, and now we can use joinAll. Save that. And again, in a simple example like this, I don't think we're going to see a huge difference here. I could try playing with these numbers. I actually haven't done that, so let's see what happens if I do that. And let's just save that. So world, of course, is still the shortest, but let's make that one 600 and that 300 and save that. So that's cool. That's a little bit better. Now I do have things printing in the right order. So hello takes 300 milliseconds. It prints first. World takes 600 milliseconds up here, so it prints second. And then the background task takes 1 full second, so that's why that one's printed third. I apologize for the blip. I had a little problem over here, so I restarted that. So I was showing joinAll, so I come back to joinAll. And then I have some notes here about possible joinAll advantage. The first possible advantage was concurrency, so joinAll joins all the fibers concurrently, which can be more efficient than waiting for them sequentially, and I just talked about that. Scalability is another note here, and this is really scalability from a programming standpoint. It just says that you can easily add them to the list that I passed in here. And that's an important point I glossed over, is that this needs to be some type of list or iterable right there that you pass into joinAll. So that is a good note right there. Simplicity, it reduces the number of lines of code, makes the intent clear. And then possibly a very important one comes to error handling, and that's if any of the fibers fail, joinAll will collect all the errors and combine them into a single failure. And I show that in a future video. Okay, things are getting a little cramped here, but I want to try to show a visual diagram for this code right here. So at some point, I'm probably going to have to push that code up off the screen. But we just saw that code there, so what happens is we start at time 0. Right away, we fork the background task and start that one. So that's this fiber here, or that fiber, I should say, is in this column right here. And then what we do is we fork print hello. So that one starts, and that's this column right here. And then the third thing we can do is print world. We fork that, and that's this third fiber over here. So basically you can think of time going down here, which I do show over in this first column right there. So we had forked all three of those. And then essentially what we're doing is we're saying we want to wait. We want to join all three of those fibers is what we want to do. So this one over here is sleeping for 1,000 milliseconds. This one is sleeping for 750 milliseconds. And this one is 500 milliseconds. So I could tell you that as time goes on right here in this first column, which is the main fiber right here, this whole first column, what we're doing right now is we're waiting. And as time goes on, if you look over here for the ends, that's what we're waiting for. So this one ends at 500 milliseconds, so it prints world and then ends. So now that one is finished. This one sleeps for 750, prints hello, and then ends. And then this one, after 1,000 milliseconds, prints and then ends. And then you can see all three of those come back to the main fiber over here. And because there's nothing else to do in that main fiber, then it just comes to an end right there. So this area here is something of a visual look at the previous code. And as usual, I hope both a code example and this visual discussion are both helpful.